I am sick of all the misconceptions about running AI locally. That you need $100 in hardware. It's gonna be so slow and it's gonna be so dumb. It's not even worth it. Case in point, my little cute little handheld laptop thingy. It fucking generates like 40 TPS, and genuinely the quality is not even bad. It's pretty good. It's pretty fast, and this runs on a laptop. Like, I mind you, like if you were to use an actual desktop, like my little goofy setup here, it goes even faster. There has been so much research, so much work to make it so that it's runnable on consumer hardware, so you don't need a supercomputer. If you have like a decent gaming computer, you can run it. And like these small models that you can run on your computer are so smart that they're actually rivaling Claude 4.5, which is a 6-month-old model. And like I said, if you have 6 gigabytes of VRAM and 24 gigabytes of RAM, you can run it. Now, those are just the medium models, but the bigger ones, which I'm not gonna cover about, is rivaling Claude. And you're not running this. You need like, you actually need a supercomputer for this one. But personally, I think they're good enough that I've personally gone full local. I don't pay these little big cloud service providers any money. And I don't know, it is just liberating. It's low cortisol. I got, lower cortisol. I'm more happier, got a bigger day. And you might be wondering, okay, so these are dumber. Like, what can you actually do with them? Personally, I have hooked it up to an agent, so it'll just automatically do stuff for me. Like, I can just say, oh, go to a website, log into website, post X, and it's just really nice to have your computer do something. Like, you can just tell your computer to do something, and it would actually do it for you, which is really nice. In fact, I'm gonna launch it right now. You find 10 cat pictures. God, it's working. Look at them go. And you can see that it is not slow. It's decently fast. Oh, look, it's slowly filling up now. Now this is just a cute little application, but personally I have done I don't know, I have a list of people, but I just have a little hobby, a little fetish of putting people into the list and watching them, but we don't talk about that. And they are also good at coding. Like, you can actually just use it to code, and personally I've used it to code for stuff I don't care about. And personally I don't do this, but I think a lot of my audience, a lot of you guys would enjoy this. But you could use it for fucking AI girlfriend shit. Like, I know my big shit post. And yeah, if you hook it up to a front end like Silly Tavern, you could do some role playing stuff with it. So it is just better. Like, there is just so much advantages. Now, I'm not gonna grandstand here and say that it's all rainbow and sunshines. Like, at the end of the day, this frontal models, this big models, Claude, Fable, whatever, fucking Google, fucking OpenAI, they are just smarter. They are just better. Usually, it is slower unless you have a beefy device. It could be like half as low at best, and yeah, you sometimes have to use more tokens to solve the same problems, and it is generally more expensive. It is just expensive because a lot of these subscriptions, API, even APIs, they are subsidized by a lot, and here you are just paying for the raw cost of electricity. And if you don't actually have hardware and maybe you have to upgrade, that is also another cost. And like, I don't know, one thing that I got pissed about people a lot is that they don't factor in electricity cost. They have like a fucking 8 GPU fucking setup and be like, oh man, look, it's so much cheaper than Claude, than Fable. But no, I want to ground you to reality. Electricity cost does factor in a lot, so that is definitely something to consider. But despite the caveats, I think it's still worth it. It's definitely worth it. Like, you should do it. Like, I like self-hosting. I fucking hate big cringe AI companies. And local models are good enough. Like, generally, they are smart enough. I like owning things. I value privacy a lot, and it's just fun. It's just awesome. And one thing I do want people to consider is that how, like, despite like considering how many cyber attacks are happening, it's not a bad idea to stop or reduce online services. Like, I don't know, I'm a full time goose farmer, and you should probably take my opinion into not that much account. So honestly, I want to spread the local LLM brainworm, the little gospel that running AI on your computer is very attainable, gospel. So I want to teach you how to run these types of AI. Now, some things to take into account is that I might gloss over some details. So please pause to read. You might have to ask the AI for specifics, or the AI that we're gonna set up, you can just go ask it some small details, because this video is gonna be quite information dense. Like, I just finished the mind map, and I just dumped all the information that I know, all the information I think someone should know if they wanna get into this. Now, I want you to know that I did not use AI to make this video. All this information. It might seem contradictory because I'm teaching you how to set up AI, but trust me, I'm just fucking sick of this AI psychosis people making guides. They're shitty fucking guides, and like they literally just ask the AI to make a guide for them. It's like it's fucking shit. Now, I want to focus on like the hardware that's attainable to the average person, which is probably like mid to high range computers, which is like 8 GB VRAM to 20 plus 24 GB VRAM, or maybe even 32 RAM. Like, if you have less, it is still possible, but just stick around. I'm gonna show you how to actually run it on lesser hardware. It is still possible, but it's just not gonna be comfortable or easy. Now, to start off, how are you gonna run it? We just need an inference engine. We need a program to actually run the models. Now, this is actually an easy choice for consumer hardware because everything uses this one program called Llama.cpp. Llama.c++, not Chinese Communist Party. Goddammit. Now, I suggest this for if you want to do role playing, you use this Cobalt.cpp. If you want like a general open source program where you can do text generation, text to speech, and more, you probably want to try Lemonade. The next thing is LLM Studio. It is proprietary. It is like a product, but it is decently popular and it just works TM. There are some caveats with this with LLM Studio, but if you just want something rock solid, pick LLM Studio. If you just want something easy and you've tried Lemonade, it's too buggy or whatever, just try out LLM Studio. And if you sort of want to be more advanced and like you want the fastest speed, the fastest features, more customizations, and you want to push your device to the limit, I suggest Llama.cpp, like the bare Llama.cpp. Fuck, this guy's Chinese Communist Party. All of these programs actually just run Llama.cpp at the back end. So this other programs just has features to make your life easier. However, like one thing I just want to warn you about is Llama. Don't fucking use Llama. It's fucking dog shit. Like, trust me. Now, whatever I'm gonna say, it's alleged. Do your own research, and I'm not suicidal. I in fact can swim. Like, I'm not gonna fucking drown. But Llama has done sketchy shit in the past, like hiding attribution licenses, source codes, wherever. And they are quite hostile to open source model formats, which is GGF. And it's mostly so that they can push their own format and their own cloud service. And yeah, Llama, in my opinion, they care more about their investors versus you. So if you see someone shilling or talking about Llama, I'm assuming they're talking about the local Llama. If they're using the cloud Llama, then I guess it's a bit different. But if they're talking about using Llama locally, their Minecraft base deserves to be griefed. We need to bed trap them in Minecraft. Send them a little orbital strike cannon to their little Minecraft village and put them in a dilation machine in Minecraft. And remember, this is all in Minecraft, and yeah, this should also happen. Like, fuck those guys. Now, it's definitely daunting to select your own model, but I just want to tell you that it doesn't matter. And if I were you, I would just pick Lemonade. It's probably the best out of all of this. I helped one of my Discord moderators out, and it took us about 10 minutes of efficient working, but it took a bit longer just because we were talking about geese feet, The second image, there's a good.
This one. I like the thinking process, like it's actually thinking.
Yeah, it's fucking considering the feet. Now, for this tutorial, I'm just gonna be using bare Llama.cpp. So anything that I talk about could definitely be implemented in the other programs that I listed before, but they're just named differently and they're probably easily more accessible. You can probably just double click it instead of like running cringe commands. So what you want to do is just go to this website, GitHub. You just go to Llama.cpp. You go down, You don't need to bother with most of this stuff. Just go to releases. This is 6 hours ago. Build 100,099. Obviously you have to pick your operating system: Mac OS, Linux, Android, Windows. For Linux, you shouldn't care too much about Ubuntu. It just works on all the distributions. And you pick the backend. This depends on your hardware that you're gonna be using. I use CUDA if you have an NVIDIA GPU, and use Vulkan if you have like an AMD GPU, or like literally any like an Intel iGPU as well. That's probably fine. For example, I'm gonna be using Linux. I'm just gonna say Vulkan, and you just download it. So once it's downloaded, ignore Jeffrey Epstein, unzip it, go here. And there, this is the program we're gonna be using, Llama server. So like I said, this is all terminal only. And then from our guide here, just run this command. Now this is going to download a pretty good model for its size. I'm assuming that you have a device that at least has 8 GB RAM, not even VRAM, like generally just 8 GB RAM. But you can see it is downloading. I switched to my server, by the way, so my little computer doesn't get railed and hammered while I'm recording this. Now while that is downloading, you might realize that for Linux, for example, it doesn't have CUDA. Unfortunately, that means that you have to compile Llama.cpp. I'm just gonna briefly cover it since it is quite advanced and I don't expect the average user to do this. But to be fair, if you're using Linux, there's a good chance you're not an average user. So I'm just gonna tell you to go to here, go to docs, and then go to build.md and just follow the instructions here for CUDA here. Like I said, if you're using Linux, you're not an average user, so no, you're fucking on your own there. Now, once it's done downloading, you should be able to see something like this. And you can just easily go to localhost. You should be able to see something like this. I already have some other models configured, but you should be able to just see this Onslaught Gemma 4. And once you load it, it's loading, and type hello. Bro, that is fucking quick. Make a poem about geese. Yeah, it should be decently fast because this is a This is a model for phones. There's a good chance that it's gonna be super quick. And that's literally the entire basic idea of how to set this up. This is not the smartest model we can put into your device. You could run it really quick. Yes, you can run it really quick, but it is still for phones and it's obviously not good. So before we move on, I'm just gonna teach you how to quickly clean this up. So you can make a model, you can make a file named model.ini and then just put this in. And like while we're at it, let's add another model. We are able to launch it with this command now. Now, once we've launched the command, you should be able to see something like this. If you go over here, you can see Onslaught, the one that we had earlier, and Gemma 4 and Qwen 3.59b. Once you click on this, it is just going to download it. So that is the basic idea of how to use multiple models very easily. Now, I've been telling you to use this command to run it, but you can also add more stuff. For example, model max 1. It just makes it so you can only load one model at the same time. It's pretty useful. And sleep idle seconds. It would unload the model, so it won't use VRAM or RAM after like this amount of seconds. For me, I set it to just one model at max. And for the sleep idle seconds, I just set it to 900 seconds. So in 15 minutes, it's just gonna unload. Because personally, I do just have it on at all times. I just have the server running at all times. And I do sometimes forget. So that is like something nice. And if you know a bit more, instead of using HF, if you can actually just download them manually from a website, or you have your own custom one that you want to use. And yeah, there's some just useful information here. Now the next thing I want to cover is context. Now context is pretty much how long chats can go for. So you can see this entire poem and thinking block that takes about 2000 tokens. So for reference, like one token is around 0.75 words or 4 characters, something like that. And for example, the entire B movie script is actually like 14k tokens. Now, by default, it's just gonna give you the max amount of tokens you want. However, there is a flaw with the default settings, is that they give you 4 parallel slots. Basically, what that means is that you can generate 4 things at the same time. Like, this is cool, this is nice, but like, it is not like necessary for the average person. So, yep, it's cool. You can generate like 4 things. Yippee. Now, the big flaw with this is that, for example, if you have 256k context, if you have 4 slots, you would have 4 times 64k. A lot of people, myself included, just prefer one slot, but you have the full 256k tokens. Just set it to 1 so you can get all the tokens you want. And then if you want to connect to other programs, there is information here. And the really nice thing about it would just know whatever model that you set up. So you can just easily select them over there as well. So that is pretty cool and pretty nice. Now, hopefully with this information, that should give you the basic idea of how to set this up. Now, if you're using something like LM Studio or Lemonade, I don't think you have to touch anything. The only one you probably want to touch is parallel. Set this to 1 or 2 and it should give you more context. Now, at the moment, there are 2 models that's pretty good at the moment. This would change depending on like the AI landscape. Like, there's always new models getting released, and I want to stress this out because I still see people using like Qwen 2.5 because ChatGPT recommended it to them. And if I fucking see one of you guys, I'm gonna crash the fuck out. Because that is a 2-year-old model. That is like an old as fuck model. You have to understand how old that is. And if you're watching this for some reason in 2 years, if you're not using Qwen 5.5 or this Chinese model that I just made up,
中国共产党通用人工智
I am still gonna crash out. Stop using like 2-year-old models, please. So at the moment, the models are Qwen 3.6 or 3.5. They're pretty similar, and Gemma 4. Now these 2 models have different ideologies and different uses. Now Qwen is just better at coding. It has better reasoning. It can think better, and especially in coding benchmarks, it just fucking destroys Gemma. Like, if you look over here, this is Qwen, this is fucking Gemma. It's just fucking, it's not looking good for Gemma. Like, look at this. For coding, it just destroys Gemma. It does really like thinking, which is a disadvantage, where it just thinks a lot. Because of all the thinking, it just fucking destroys Gemma. On the flip side, Gemma, they want to make their models information dense. It has better multimodal capabilities, and the unique thing about Gemma is that they can do audio. Now, because they're more information dense, they know more languages, more facts, and they just know a lot more. Now, Gemma is really good at writing or any task that needs productivity. It's also decently uncensored. So, because of this, it is the pick. It is the chosen model for role playing, writing, and whatever. In my opinion, Gemma is just better for chatting and general use. Like, if you just want to ask it something, Gemma probably knows it. Now, personally, I suggest both because they have their strengths, they have their weaknesses. And this is your own hardware anyways, and it's literally free, just download it. Now, that said, this actually the model recommendations I suggest. With these specs, you should be able to run their respective model with no issues. You get the idea. The ones we got earlier is Gemma 4 E4B. It is really good, but it's mostly made for phones. 9B, it is better for coding, like I said. If you're wondering what the B's are, that is the parameters. That is how big the model is. And usually that's how smart the model is. So the bigger the beast, the smarter it is, and the more space it would take up, and the more compute you need, the better GPUs you need. You can just have a look at the notes of what I think of each model and what I just recommend. However, you might notice that for the requirements, E4B needs 8GB RAM, this needs 8GB RAM, 12GB, and then it suddenly just jumps to 24GB VRAM or 8GB VRAM and 24GB RAM. That is a unique thing with MOE models. The rest of these are dense models, where instead of fitting it all inside VRAM, you can actually just split it between your VRAM and your system RAM. Now, I think a lot of people get confused about what MOE models are or what dense models are, but this is a rough explanation. So just comparing Qwen 3.617b and 35B A3B, 35 A3B is a MOE model, which means it needs only 3 billion parameters per calculation. So this means that it is fast and very smart. And that's just how it works. Like, it's like a 3B model, but it's a lot of 3B models all at once. Now, this means that you don't need to fit everything inside of your RAM. And at minimum, 3B stays inside your GPU and 35B stays in your RAM. Now this, like I said, this is very accessible. And compared to a dense model like the 27B, it needs all 27B parameters for calculations. So if this doesn't fit inside your GPU, if you don't have like a 24GB GPU, it is gonna be super slow, like generally super slow. So good chance you will have this. Though there are some considerations. MOEs are kind of dumber compared to their size. For example, the 27B is actually smarter than like the 35B in a lot of the benchmarks. Let's go up. The MOE scores 47.7, the dense scores 52.2, and that is a general trend where the MOE, this one, is just dumber than this one, which is the dense model. Now, for reference on my laptop, I am getting about 7.5 tokens per second with the 27B, which is pretty slow. But on the 35B A3B, I am getting 30 tokens per second, which is really, really fast. If you don't have 24GB of VRAM, or maybe even 16GB of VRAM, you should probably stick with MOE models. It is more attainable to the normal person to run. Now, this is a quick comparison. Dense model is just Soldier TF2 that's buff, and MOE models is just a bunch of cute little chikawas. There's a bunch of them. They're cute and fast, but they are strong together. It's a dumb fucking analogy, but whatever. We're gonna fucking keep it. So choose whatever fits here. And the idea is you just go to Hugging Face. This is the website that hosts a lot of these AI models where you can download them. I just suggest for you to find ones made by Onslaught AI. And you're just gonna search through this. Let's say you want the 26A4B IT. You want to search for the one with the GGUF. That is the file format we're using for the AI. You just copy this. And that is the HF link that we sent here. Though just to make your life a bit easier with the model ini file, you can actually just simplify them. So context size 32K, parallel 1. That just means that all of these models will have this config, so you don't have to copy paste. Just one quick tip. And now with our new config, you just run it. Now this has a 22GB download. So while that is downloading, I suggest you ask your AI how to run this without a command line. This is pretty useful, so you can just double click something or it just starts automatically on boot. Like the E4B, it should be smart enough to just give you an advice on how to do that. Or you could just go search it up on yourself. Now, once that is downloaded and you can run it, you would have a very capable LLM for coding or agents. And you should probably check out Gemma for 26A4B. And if you're happy with it, I suggest you just plug it into whatever AI program you're using. Maybe PyAgent, Hermes is quite popular now, OpenWebUI. And you should just enjoy using it, because this is where like the rabbit hole begins. This is where it's gonna be more fucking complex. And I suggest that if you're happy with this, just go away. Just go away. Save yourself from this hell. However, we could make it faster. We could make it not crash. We could make it use less VRAM. We can make it smarter. We can make it better. And a wise man once said, 2% better. Normally, without any of the fixes and any of the optimizations, it would generate at 16 TPS per second. We could go up to 40. That is like a 2.2, 2.5 is it? Speed up. which is big. That's really nice. Now, optimization time. Let's fucking make it better. But I'll be honest, just to save you time, right? You might want to have a look at these communities. There are communities that revolve around specific hardware. And you can try searching, club your GPU/device, your GPU device, toolboxes, recipes, and then like these keywords. So for example, this one is called Club 3090. This is a community about 3090 owners, and it's probably gonna save you a bunch of time if you don't want to learn it and you just want something efficient and if you just want it to run immediately. But if you're not as lucky, we have to do it ourselves. Now, this is how I'm gonna optimize it usually. My priorities are the desired context size, intelligence and accuracy, speed, and the VRAM usage. Now, the thing is, unless you have like 1 terabyte, and nowadays it's probably like 2.5 terabytes of VRAM, you are VRAM poor. And if you're my target audience, you probably only have like 6, 8, 16, maybe 24 or 32 gigabytes of VRAM. It's still gonna be a bit tight. Now, the reason why I suggest balancing all of this around your desired context size is because it's pointless if you have the smartest and fastest model that fits inside your VRAM, but you only have like 512 context, which is not enough. And there's just more stuff here. Go ahead and read this if you're interested. Now, to start off with, if you're trying to run this model and it still doesn't launch, there are some ways to fix this. Usually, if you have problems at the moment, that is usually caused by you not having enough RAM or VRAM. Now, here are some optimizations. Feel free to pause and read all of this. Threads is just how much CPU threads it's gonna use. Less is sometimes better, but not always. It's device dependent. MMUp and MLOC, it's quite a controversial thing I'm going to cover a bit later on. But it just changes how it uses RAM. And MLOC stops RAM from going to the disk, which is very nice. No mmproj means that it's going to disable multimodal capabilities. What this means is that you cannot input an image or a video or audio into the AI anymore. That is something that people often disable because people don't usually need those. And this basically frees up VRAM and RAM. So that is one thing to consider if you want it to use less space. Now, this might be a bit controversial, but I suggest you not touch mmap or mlock because it overrides how your OS manages RAM. Try not to use it, and there is a lot of disadvantages. Feel free to read here on why you want it, why you might want to enable it and why you might not want to enable it. Feel free to read this. I don't suggest touching this usually. Now, generally, if you're using dense models, just set the NGP layers to 1. It basically forces everything inside the GPU VRAM. Now, for MOE models, I suggest you just not touch anything. Now, for MOE models, this is fair unless you're in unified memory, which just means that you don't have a GPU. You should set it to -1. But basically, you don't have a GPU, and not setting it to -1, it causes a lot of problems. Feel free to have a look at why you should set it to -1. Now, with all of this, if it's running perfectly, maybe it's faster, maybe you have more context, and it's good. Congratulations, you're now using the optimal memories. But if it still crashes, there's a good chance you're still running out of memory. An easy fix is to drop to a smaller model, or it's lobotomy time. Now, there is 2 ways of doing this. One is memory lobotomy and one is general lobotomy. I'm going to start off with memory lobotomy just because it is easier. Memory lobotomy, it just reduces VRAM usage, but it hurts the ability to remember, or it just makes it, it fucking nerfs the memory. It just forgets things. Now, memory is often referred to as KV cache, and KV cache is determined by how big your context, how you set your context to be. So this is why I said to just don't set the context super high to something you won't use, because you're going to be using more VRAM for absolutely no reason. So you might be wondering, how much VRAM does this memory KV cache even take? So for example, these two models, 3.5B HEB and the dense model 27B, at 32K, it's gonna take at like like six seven six seven gigabytes, 2.14 gigabytes, and so on and so forth. So some notable quants is the F16. F16 is a default one. Q8 is typically considered as free, and it would reduce your KV cache usage by half. Q5 is a really good balance for quality and space saved. Its inaccuracy is closer to Q8 rather than Q4, and Q4 is probably the lowest you should go, in my honest opinion. So for example, KV cache is 16 GB at F16. It's gonna be 8 GB at Q8 and 4 GB at Q4. So that is the idea. How you're gonna do it is that you just add these two launch flags. By default, if you don't touch it, it's gonna be F16. Now, quantizing KV cache or memory lobotomy is quite a complex and controversial topic. I sort of want to just teach you the basics on if you should do it, if it's worth doing, how to do it safely. Now, some consideration is that MOEs tend to be sensitive to memory lobotomy, and Q8, like I said here, is not really free. Some models are sensitive to memory lobotomy. You usually notice memory lobotomy during coding or agentic task and long context above 64K context. If it's short, you might actually not even realize it. And this is a compounding thing where it's just gonna start forgetting stuff, and it's not nice if you use longer context. Now, some numbers and some data points with attribution to local bench. Lower number equals good, bigger number equals bad. 0.05, less than 0.05 is acceptable, more than 0.01 is very bad. As you can see at Q8 for coding, it's just not even there, it's literally just the same. For chat, it's almost the same. 0.07 for till use, it's the same. Long docs, yeah, that is where it starts to hurt. But now for MOEs, right, like I said, they are not resistant to memory lobotomy at all. So for coding is the same, chat, but tool use, it fucking spikes so much even at Q8. And the last finding was Gemma, where it does not like quantization at all. The Q8 KV cache, that's look at those numbers, that's like so fucking high. That is so high. Now I'm gonna show you how to lobotomize Gemma 4 properly, but that is model specific. So in summary, I just want you to be careful on doing this, because this does often hurt the model way more than general lobotomy, which is what I'm gonna show later. But regardless, if you do it properly, you can save half, maybe even like 70% of space while not impacting the model too much. Now, these are just estimates. There is a lot of variables at play, and you should test this yourself, because it also depends on your hardware as well. It actually changes with hardware as well. It depends per model as well. There's just so much valuable variables. So I'm just gonna flash mathematics. Be careful, close your eyes if you're scared of mathematics. Basically, if you go to the model page here, if you click on one, there's a bunch of data here. Look at this data. Just have a look at this entire format. Just copy. Just pause honestly, or you could download the Mindmap later on. Check it out in the description. The next thing I want to cover outside of memory lobotomy is just general lobotomy. Now, if we look at the model page, right, you might see 1 bit, 2 bit, 3 bit, 4 bit, and you can see that they all use different amount of space. Now, if you're wondering what those are, that is the quantization again. It treats accuracy for, to reduce VRAM, and that's just general lobotomy. So while memory lobotomy makes it forget stuff, and it's just amnesia, memory lobotomy just makes it basically dumber. Like it just makes it dumber generally. Now, if you have been following the commands I've been using, you would be using the Q4KM quantization. So you've been using a lobotomized model all this time. There is this scary chart, but I'm gonna break it down for you what the bits are. So BF16 is usually 100% of the quality. This is the base model. It's usually not run for inference because it is just too big, and when you compare it to the other models, it is just the other quantizations. I mean, it is just not worth it. Now, the next best thing is Q8K. This is usually the best that you should aim to run. It's really good. And there's a Q8 as well. It's an older way of quanting. It's still good. Q5, really good quality with a pretty good size to ratio. And Q4, the one you've been using, that's the default. Good quality, and quality will drop hard after this. And it is quite questionable if you want to go further down. And IQ4, it is the middle ground, and after this, it just becomes really sketchy. So there is this one chart. Lower number good, bigger number bad. Anything above 0.1 or 10 to the power of -1 is very bad. So as you can see here, Q6 is like around here, Q5 around here, Q4 around here, and then it just drops hard. To visualize this, there is a little gallery here made by someone with attribution over here. I do think this is not a good representation. There are some flaws, but this is something that we can just visualize. Full precision, you can do the chessboard decently. Yes, a line even. Q8, the line is gone. 6-bit, then 5-bit, then 5-bit, 4-bit, it is still comprehensible. And yeah, pretty much this is just a benchmark. As you can see, it does get worse over time. And at Q2, it generally just breaks. Like, what is this? I think some pawns are missing as well. Let me check. I think, yeah, there are some pawns missing. The reason why I mentioned this, that this is a flawed test, is because KV cache is heavily lobotomized. Like, this test is using TurboQuant, which is lower than Q4. So it's dumber than Q4. And they did it especially with the 35A3B, which is sensitive to memory lobotomy. So as you can see over here, BF16 is decent. It's a bit weird. But then like for this Q8, which is a pretty big model already, it just becomes super dumb. Like that is super bad. Now I sort of want to mention this just because like it is not that bad. Like I want to do justice for 35B A3B, which the test didn't, but this is just my test with no memory lobotomy. It is worse definitely, but it's not that bad. For example, Q5KM, it is still, it's slightly off. The chess pieces are slightly off, but it seems good. And IQ4XS, firstly, there is like multiple horses over here. This shouldn't exist. It has too many horses as well. Look at this as well. And the one thing to also consider is how this is wrong as well, because this is white. This should be black. Like this square pattern should be black, as you can see over here. This is black. Like I said, it is bad, but not that bad compared to this test. So hopefully that is a decent way to visualize this. Now, I think this is quite controversial, but you should just run whatever fits in your system. So if Q4 doesn't run, you should try to go to IQ3XS. If that still doesn't run, just keep on going lower and lower until it eventually runs. I don't suggest going to IQ3 and lower, but if you are desperate, feel free to just do it, because you shouldn't stress about this, in my honest opinion. They're all good relative to their size, and just don't forget to take account for KV cache. Anyways, I really don't think you should stress too much about this. However, you should stress about this when you're coding or doing agentic tasks. So like, for example, even though Q4K is like 95% similar to Q8, which is 99.5% similar to BF16, each percentage does add up, it compounds, and it does lead to worse code. I would like compare to mathematics. Like, if you got 99.5% of the correct answer, you're still wrong. If you get like 95% of the answer, you're still wrong. That is why every single percentage difference matters. Every single percentage matters for our coding. Now that we've covered both types of lobotomization, general lobotomy and memory lobotomy, this is how you run it. We just edit our model.ini file and we just add this. You get that number from looking over here. So for example here, 4B, where is it? There, UD IQ4 _XS. Now, if you want to run KV cache quantization as well, and you just run these two parameters. Now, with this, you should know how to lobotomize your AI properly. And this is sort of like the most hardest thing to do. And this is the one that has the biggest impact, which is just balancing RAM and intelligence. And yeah, this is generally a bit hard. You might have to spend a lot of time doing this. But this is basically how much lobotomy you can get away with. Like how much can you reduce the space, requirements and get away with it. Look at this mambo. Good. Anyways, this is a really big pitfall. For example, I see people running 3.6 to 35B with Q8 or less KV cache and wondering why their AI is so bad. And yeah, that's a huge pitfall. Like people don't really understand it. And don't even get me started on turbo quant, which is like lower than Q4 memory lobotomy. People do run it and just wonder why it's so dumb. Now, hopefully you should have your desired context, lobotomy level, your desired model. And let's make it faster. It's zoomy time. Now I want to warn you that a lot of these are hardware dependent. It depends on your hardware, and you have to tinker with it a lot, quite a lot, like extensively. Now let's start off with the most time consuming. And now I don't really want to cover this in a video just because I don't really recommend it, but the information is here if you really want it. But the basic idea is these models are usually divided into blocks. You get the information from the page again, you apply the mathematical formula, and you get the amount. And this is also information on how Llama.cpp would fit your model usually. These are just approximates. I didn't even calculate it properly. And here KV cache proj offloading. Instead of using VRAM, we could use system RAM, but then it's gonna be a bit slower. For example, KV load, it might be good if you're really desperate. It's a bit of a dark art, as you can see. It's like this is not talked about because it is really obscure and people don't do it, but it is useful. There's also batch size. This is one thing that is actually pretty good to mess around with. But you could reduce this number, and it reduces VRAM. It actually sometimes increases speeds, and there's a lot of hardware things to consider. So you have to play around with this. But generally increasing it would just increase the reading speeds, and it is really weird depending on the hardware, like I said. The last thing I want to briefly cover is checkpoint size. As you use the AI, the RAM usage would just increase, and as chats go further. This is because of checkpoints, and it lets you restore chats without like the long reprocessing, and you can just rewind chats without it taking like a long time. Probably I don't think you're gonna touch it that much, but like I said, this is good information to have. Like I said, in my honest opinion, you shouldn't do any of this, and you are fine not touching this. But obviously, if you want to push like your hardware to the limit, like you're gonna have to spend like a lot of time doing this. Like you could definitely make it go faster, more context, whatever, but it is just way more complex, and I don't think I can even cover it in this video of like how complex this is. Just doing it automatically is fine. It is generally fine. Like doing it manually is just hell. Next up, the thing that I really want to mention, and one thing that you should definitely bother with, is speculative decoding. There's a lot, but at the moment I'm just gonna suggest this two: MTP or Ngram. So MTP, it generates multiple tokens ahead. So instead of like generating one token at a time, it generates multiple tokens ahead. So this can give you 2.2x generation speed boost, which is a lot. However, there's a downside where it reduces your prompt processing, which is the reading, by 5 to 30%, and it will use more VRAM. Now, the speed boost depends on the task. It's more effective in deterministic tasks, which is like coding or information extraction, and it's less effective in creative tasks like writing or general chats or just anything creative. And for the model, it is more effective for dense models, so you can expect a 1.4 to 2.2 speed boost. And for MOE models, you could actually slow it down if you are not careful. This is the reasons why. Now, the next thing I want to cover about is Ngram. it just copy pastes similar tokens, so it's a bit slightly slower, but there is a massive generation speed when it's activated. The VRAM is also not bad. It's like 100 megabytes. It's generally so small. It is just copy pasting. Like if you find your AI copy pasting like a bunch, this would help. So for example, if you just tell it to change a single line, a single word in a paragraph, it would go really fast. Or you give it some code and you just tell it to change one line, it's also gonna go really fast. But the thing with this is that while it might sound good on paper, it might not be as good in practice. For example, coding harnesses rely on tools which change specific lines, so it's only going to change one line, so it might not be worth it. But if you're those kind of people who like just copy paste code and then like tell it to change one thing, this is where it's gonna be pretty good at. And this is how you're gonna activate it. Now I want to cover MTP a bit more. Basically, it generates extra tokens. Now, these extra tokens are calculated whether it should be accepted, which speeds it up, or rejected, which slows it down. Now, acceptance rates depends on the task, which leads to the variation of speed. That's why some tasks are just faster and some tasks are just slower. Like if you generate more tokens, which is this variable, it leads to a higher rejection rate, which means that it might be slower, but generally it does speed it up. Unless it's an MOE, then yeah, you're kind of boned. To use it, you need a different model. It's built into the model, or it's a separate file. For example, for Onslaught, you can see it's Qwen 3.635B A3B, and it has an MTP GGF. And this is the models that has MTP enabled. They are a bit bigger just because of like how it is. For example, if that's not a thing, for example over here, there is also this MTP file that you can just load it in. So there's two types of models you can activate MTP. Should you turn it on? In my opinion, dense models always have it on. For MOE models, you should probably consider not turning it on at all. So hopefully that is enough to like teach you all about speculative decoding and mostly MTP, which is just a free speed boost, or almost free speed boost. So that's definitely one thing you should consider. The next thing to consider is just optimize quants. There is quants specifically for different hardware. So MXFP4, this is really good for Apple chips. MXFP4 also runs on RDNA 4 AMD, which is like the RTX 9000 series, and NVIDIA Blackwell, which is the 50 series. Usually these two are worse than they're dumber than the normal quants that we showed earlier. However, they are just faster. Now, people have reported for it to be 40% faster in generation on Apple devices and 50% faster prompt processing on NVFP4 for Blackwell. So this is a pretty nice speed boost, but it is dumber, so just be aware of that. Now, the next thing is quants optimized for MOEs. For example, Apex, which is adaptive precision for expert models, blah blah blah. This is actually like a 20% to 33% faster generation. This is pretty nice, and I do really like it. Now, this usually leads to it's usually dumber on average, but they do have a lower max KLD, and they claim that this is better for real world performance. But honestly, I do feel like they are dumber, but they are faster. So they are faster. That's like one thing to consider. Now, there is a lot of labs. There's a lot of companies, AI labs that do try to make it smaller. There's a lot of examples, but for now, there's also ShapeLearn. And the one thing that's interesting is that their smallest Qwen 3.635B A3B model is only 9.42 gigabytes. So that is really interesting on how small they could make it. But obviously, I did try it. It is kind of dumb, but it is pretty cool that they can make it that fast and that small. So that is pretty much for the optimized quants. Basically, you are trading intelligence for speed. Next up is just free performance tips. Most controversial one is using Linux. Using Linux just gives you more RAM or VRAM. For example, on my laptop, Windows 11 uses like 10 gigabytes of VRAM that's already gone that I can't reclaim. But Linux with a heavy desktop environment, which is what I'm using right now, it only uses like 2.8 gigabytes. So I have way more RAM that I can run the model in. And there are desktop environments that use even less RAM. So like less than 1 gigabyte it's very optimal. Like 0.8 gigabytes, it's also doable. And if you drop to terminal only, where you just kill the fucking the monitor, it is even lower. And this one meme that like pissed people off: 4 GB RAM on Linux, strong Tom. 16 GB RAM on Windows, it's just all Tom. Very very controversial meme for some reason, but it is very true. And there are also a lot of advantages to using Linux. Like I think it is like 10% faster, though I haven't actually seen some tests into it. Programs are optimized for Linux, and like a lot of AI servers run on Linux, so the optimizations for Linux is there, but not really on Windows. For Mac OS, I think is also better for compared to Windows. The next big thing, the really big thing, is actually compiling Llama.cpp yourself. This is the biggest advantage of Llama.cpp. If you compile it yourself, you would pretty much just optimize it for your hardware. This is generally a 10 to 20% performance increase. The downside is that you need to recompile it every time you update drivers, or you need to update stuff like that. Now, for me personally, this actually increased my generation tokens per second for my laptop, my handheld thingy, from 18 TPS to 26 TPS, which is a massive 44% increase. Like that is really big. Like now there are ways to use like front ends and still have the benefit of the speed, but I'm not gonna cover that. It is very dependent. Now, how hard it is. Now, how are you gonna do it? For Linux, it's literally just one command, and it's gonna compile it yourself. Arch Linux, by the way. This only takes 4 minutes on my little laptop. It's a bit less on my desktop as well. But for Windows and like I think Mac is also Mac is fine. I think for Windows it's a bit fucky, where you need to find a correct CUDA version with the correct NVCC compiler with the correct CPP compiler. It is just fucked. There is probably an automatic ways to do it on Windows, but I am just not aware of it. But you can just read the guide here. There is a really good guide on how you're gonna do it and how you're gonna compile it. I don't see like someone not technical doing it, but that's like one thing that I guess you should try doing if you feel like it. And the last optimization, which is really goofy, but it is actually normal and it is actually like done in production environments. It's just blinding yourself. So you could reduce resolution. It reduces VRAM for sure, but you could also just unplug your monitor, but you can't see, and you need to remote access into it. I don't suggest people doing this, like normal people doing this, but that is like one thing a lot of like even in production like servers they use this, they do this. They don't have like monitors obviously. And one quick tip that I actually suggest people doing, and I actually taught someone to do this, is that you can unplug your monitor from your dedicated GPU to your motherboard. This basically forces your iGPU or raw CPU for the visuals, and it's gonna use system RAM instead of VRAM. So it is nice to free up a bit of space. So with all of these optimizations, personally using my laptop as an example, by default I have 16 TPS. By setting NGL to -1, I get 18 TPS. By compiling it, I get to 24 TPS. It's actually a bit lower. Let's do 6 to 26 TPS. By using an Apex quant, I get to 29 TPS and 30% TPS. But I get less accuracy. And with MTP, it actually goes to 35 TPS on average, but it goes to 40 TPS peak, and there's also a longer processing speed. For reference, I can just quickly load up Llama.cpp on my thing. For reference, I am recording at the moment, so it's definitely not gonna be as fast. But let's just say, hello gamer. 26 TPS. Yeah, it's a bit less because I'm recording, but that is a good speed. This is really usable in my opinion. Hello gamer, what's good? Yeah, it's just yapping. Now, for example, for coding as well, let's do the chess thing. I've been using it a lot. 32 TPS. As you can see, yeah, it is a bit faster. It went from 29 to 30 something. I'll just let it think for a bit. There we go. It should be hitting TPS. This should slowly increase to 40. Let me just try to show you on the terminal on how fast it actually is. Yeah, it is going to 35 TPS. Like I said, I am recording right now, so it is definitely less, but it does go to 40, which is really, really nice. Now, with all of this, you should be able to get like the context size you're happy with, the intelligence and the speed, and now I just want to finish up. Now, this chat templates claim to improve like your performance, that your AS performance. So like it would just stop looping. Like there's some issues here that people found. It fixes bugs. These are made by the community, so they are a bit sketchy. They're a bit sketchy. I'm not too sure if it actually fixes anything. I don't feel like it fixes anything. Personally, I do actually run it. I think I'm just running it for the vibes, honestly. Now, there are some model specific settings that you can enable. For example, some settings are better for general tasks and some settings are better for coding. And Unsloth, once again, is a really good good resource for this stuff. For example, for general tasks, for example, is better at temporal 1.0, blah, blah, blah. For precise coding task is better at 0.6, blah, blah, blah. And then there's like other modes. And there's also like disable thinking if you don't want it to think by default. You can do that. Now, these are my actual configs that I'm happy with. Like this is just a balance of speed and intelligence I'm happy with, and this just runs in the background. And this is just for my laptop, and feel free to read all of this. And I will show off like an updated version, probably in the description. Not in the description. It's probably gonna be on my Patreon where I'm gonna link the downloads for this, and I'm probably gonna change this as well when I actually release it. Now there are a bit more information I want to share, but I don't really know where to put it. But there are just some of my warnings and common pitfalls that I just suggest people not falling into. The first thing I suggest is to try to stick with base Llama.cpp, because there is a lot of Llama.cpp forks. The first one is the good ones. There's huge shifts, there's huge upgrades over here. For example, optimization paths, for example, Llama.cpp, and a different KV cache quant. There are a lot more. There is like generally a lot more. They are like optimized for specific hardware as well. And there's like a lot of forks. People have done a lot of stuff. There's a lot of improvements over the base Llama.cpp. Generally, I don't really suggest you do touch them unless you know what you're doing. But for example, ik.llama.cpp is good for hybrid plus CPU, hybrids GPU plus CPU inference. But it basically means that it is faster. It's just faster. It's like 20% faster on average. But you only need but you have to use NVIDIA GPUs plus modern CPUs to actually take advantage. Now, the one thing that is also a bit controversial, I think, in my opinion, is turboquant. It increases accuracy for lower lobotomies. Now, if you were alive this time, if you've been looking at tech news, those tech YouTubers were like, oh, this is gonna reduce RAM prices. This is gonna make the RAM prices go down. And that is like the optimization here. It didn't, by the way. Like the RAM price did not go down. It probably went up again. So those fucking tech YouTubers, they have no idea what the fuck they're talking about. Now I wouldn't stress too much about this because they Llama.cpp, the mainline, did do upgrades because of this paper. So I wouldn't stress too much about this. Now there's a lot. Like I said, I don't wanna. There's just a lot of forks that are useful for some cases. I'm not gonna cover all of them just because there's just too much. However, I just want you to be careful about some forks. Some forks are made because their AI slop pull request got denied and they're banned from contributing to Llama.cpp. This is quite controversial, but Llama.cpp is very hard on the no, like AI, mostly AI generated content or pools. The idea is like if you use AI mostly to try to contribute to the project, you will just be banned. If you want to contribute to Llama.cpp, at least you should know what you're trying to do. Now, personally, I do think this is a good thing. Like, I've seen projects just get fucking ruined by like an AI taking over, and like nobody knows what the fuck it's doing, which just increases complexity but no improvement. Like personally, for a serious project, AI should be treated and used as a tool and not the one driving the project. Now, one example is PewDiePie's Odysseus. I don't think if anyone's covered it, but I've been watching it, and it is generally just a shit show. Like for example, one file is 33,000 lines long. There's like day zero fucking hacks, remote code execution, and prompt injections, which just means that if you use a program, you could have been hacked. There's like so much vulnerabilities. Now, the next pitfall that I find people falling into is Finetunes. Now, what are Finetunes? It is basically a tweaked version of the base model. So they take the base model and they train it a bit more. So they change how it thinks, how it speaks, teaching the model new information. And it is effectively used to turn a general model into a specialist, like a law or a medical expert. I don't suggest any fine-tunes except the uncensored fine-tunes. This isn't actually exclusively for gooners. It doesn't refuse medical questions. For example, if you're in the middle of nowhere with no cell reception and you have a broken leg and you don't know what to do, like the censored models, the base models will just tell you to seek help, gaslight you that you actually have a cell reception and you should just call emergency services, which is not very useful. While the uncensored versions would just tell you, first aid advice. It's pretty good. Now, I really want to emphasize that the fine-tuning space, this part of the community, is just a shit show. Like, it is so bad. It is just a shit show. For example, like people would claim that their fine-tune is better than the base model, but there's no benchmark. Showing the benchmark, it's good in the benchmark, but then like in real life, it's fucking horrible. There's also like cult-like behavior. It's a bit terrifying. And I just want to put this up here. Base models are often better than the fine-tunes. Like the original is usually better, and don't bother with them. It's really good if you want drama. The people are stealing code. I'm how CS, and I'm bots promoting the fine-tunes. If you dare criticize the model, you're gonna get banned. If you do benchmark and you do test on the models, you're gonna get blocked and banned. So it is just a shit show. It's fucking bad. Now, for example, the actual fine-tunes is like I said, specialized on a specific topic such purpose. So for example, Gemma exists for medical stuff. Translate Gemma exists for translation, obviously. And there is a lot for gooning, like how like changing how the model speaks. But I am not gonna show that. I'm not gonna show that. You can probably find those by yourself. Hey boss, what's the plan? Who the fuck are you? I thought I hired goons. The next category I'd say is the uncensored / heretic / obliterated ones. Though for all of this, I just suggest heretic if you can find those. But basically, they all do the same thing. They are fine-tuned to do no refusals, so they will just do whatever you want and whatever you say to. It is really good if you need it. You just don't run it all the time because they do get a bit dumb. So always try to see if you can get away with the base model. You can uncensor them yourself too. There's Heretic. I do suggest Heretic because they're just open about benchmarks and results. Their methodology is open. They don't do cringe shit. Like a lot of the drama is actually like this few things. They also contribute a lot to the drama, the uncensoring part. Heretic is just a no bullshit, and they just don't do cringe shit. Honestly, they're not cringe. They're open about the benchmark results. If you say that they're bad, it's like, oh yeah, they're bad. We're just gonna make it better. But they don't ban people for mentioning that. So that is like a really good thing. That's why I like them. Now the next part is the quote unquote better models. So they're either distilled fine-tunes or the hype fine-tunes. And for example, it's like Quopus, Quable, Quithus, etc. And if you look over here, this is a bit silly now. This is a bit silly now. Like it is so long. I don't even know what the fuck this is. I mean I get the idea, but like it's just silly. Now they claim to improve the base model by fine tuning it and on outputs of bigger and more capable models. It's like we're gonna try on Fable outputs or Quit or Mythos outputs or Opus outputs, and it's gonna make it smaller and it's gonna make it smarter. But you put a lipstick on a pig, it's still a pig. Like there is a lot of problems with this. Like thinking blocks of cloud models are already obfuscated, so you actually cannot do this effectively unless you know what you're doing. And because of modern training methods and post-training methods, you cannot do this without actually degrading its performance on other tasks. So it looks good on paper and benchmarks, but it usually performs worse in real uses. And the thing with fine tuning as well is that they do tend to loop way more. For example, here, do you know the lyrics of the Red Sky in the Sky? Yes. Red sun in the sky, red sun in the sky, red sun in the sky, red sun in the sky. Now, for example, right, for the distilled models, Quopus 35A3B, using the chess benchmark again, this is what it came up with. Like, that is so fucking bad compared to the base model. This is not even a chessboard. Like at this point, like I don't even know what this is. This is a common thing. This is a common thing with like all of these fine tunes. And another bad fine tune is this is just an example of all the drama. So there's this model called Quithos 9B Claude Mythos 5 1M GGUF. It's just worse. It's worse the worst performance. One funny thing is that he's always advertising himself in a fine tune. So if you look over here, like over this discussion, reasoning has no reason to spill your name all over the place. I just saw the model card and will not try. Basically, it would just like the AI would just spit out his name over and over again, which is that's kind of fucked. Oh wait, fuck! I should realize that. Okay, this is a really good part. This is a really good part that I want to mention is that they do delete critics and benchmarks. This is really funny. Deletes all users who criticizes or questions the quality of his models, and that's how you achieve Mythosphere. And the guy is just deleted. So that's an example of like why I think this is a shit show. There's also like questionable things. Like it is good for marketing. It is good for on paper, but like for example, this model increases the context to a staggering 1 million. That is like really interesting. That's really good on paper. However, it's not usable. It's barely usable at 32K. Like it is really bad even at 32K. So there's no point increasing it to like 1 mil. So it is just really bad. It's kind of funny of how bad it is. For the last example, I want to show you like a decent fine tune. When I made this, I was actually kind of bashing it, but like for example, this one model called, let's just call it Le Shilbird. It's fine-tuned on Qwen 3.5 and Gemma 4, and it's fine-tuned for coding plus agents. As you can see over here, it is just somehow better at coding and agents. And for example here, right, using the same benchmark, which is a chess benchmark, 35A3B, the base model, I think it's this horse. This horse is not supposed to be here. This horse is also not supposed to be here. But if you check out Les Shilbird, the horse is gone. Peter, the horse here. And the horse is also gone. The little knight. Like this is just really good. This is really better. And it does behave differently. For example, it's instead of trying to solve a problem once, it's gonna review and make sure it's proper. So like the first code is a duplicate. Has a problem, so it recodes it again, and it is somehow better. It is somehow better. There's still some issues, but it is somehow better. It's better for coding, but generally I think it's worse for everything else. So I think this is a bit controversial, but I feel like this is actually a good fine tune. And if you're wondering, the name is Ornith. Yeah, it is actually not a bad fine tune, and it is just better at coding and everything. So it is, yeah, they do exist. These better fine tunes do exist, but as always, I still want you to be a bit careful about them. And that is pretty much it about Finetunes. And yeah, we've been through a lot. This is quite a long video, a long mind map. And there is just so much stuff that I didn't really cover. Like the video's long, my upload schedule isn't the best. Like I wouldn't be surprised if Qwen 3.6 is outdated and Qwen 3.8 already exist. There's always new research and improvements. Like for example, MTP, which increased speeds by 2 times, was just implemented like a month ago. It's brand new tech, and there's just so much to cover. There's so much things to learn, to show off, to teach, and I just can't do it. I just physically can't. Maybe I'll split it to smaller videos in the future. But some advice if you want to learn more after this video. This is like some forums you should look at. There's the Llama.cpp discussion page. This is some good information as well. If you want to play around with the models, there is also information here at the Hugging Face forums. And one last thing is Reddit. I don't like recommending Reddit. I hate Reddit. But r/slash local llama is also not bad. This is a decent form as well. And look, Qwen 3.8 is coming. I wouldn't be surprised if Qwen 3.8 already exists when I upload this. There are other subreddits, but the regulars there are too deep into AI psychosis and give horrible advice. And there are still, dumbasses, of course. This is Reddit. But I like it when someone posts the research and they're using 2-year-old models and people just call them fucking dumb. It just shows that they have no idea what the fuck they're talking about, and like their advice is just dog shit. That's why this is probably the only sane subreddit to visit, even though it's not that good. Also, one thing I didn't put is the NVIDIA forums. I'm just gonna put it on the screen right now. NVIDIA forums is also not bad. Now, lastly, there are private discords, but those are kind of cringe. And if you join my Discord, you'll only find gooners on my Discord. So these guys are probably not gonna help well. And unless you join and make the change, I'm just saying this right now. If you want I want a good community about local models, because that's one thing I'm really passionate about. So if you want to learn more about this stuff, can you just kick out the gooners, please? Can you just join and like share on the gooners, please? Thank you. Unless you want to run like gooning shit on your computer as well, then you're also welcome, because it's local models. Some more advice is to not trust AI blindly. Do your own research. Like I said, people still use Qwen 2.5 because an AI recommended it to them. And honestly, I don't blame them completely. Not completely, because if you like search to Google, right, they do fucking make up shit. For example, Qwen 3 Coder Next, that is like a 1-year-old model that's already quite old, and there's no reason why you want to use them. For example, look at this Gemma 426B, that does exist, but 35B does not exist. And for some reason, Qwen 3 VL8B is recommended as well, which is it's already quite an old model as well. And the next thing is quite a big topic, and one thing you should be careful of is AI psychosis. Like it's fine. It's just don't trust your AI too blindly. But the most damning thing, the most scary thing is like the people under AI psychosis, where like there's like people trying to fix stuff that's already been solved, like reinventing the wheel. This is easier because AI is you can just make an AI code for you. So that is like one annoying thing, and it's also like why I mentioned about the Llama.cpp forks. Don't There's a lot of forks like this where they just use an AI to make it, but then it's like it's already been done. So like why they even use it? And generally, a lot of people don't know what the fuck they're talking about. Like an AI said it's correct, so it must be correct. It is, yeah, it's just not as good. And one thing that is probably controversial, but if someone explicitly says to turn on FA or flash attention or even use Jinja, they're under AI psychosis. Because for some reason AI likes recommending this to be on, but by default it's already on. So it is kind of dumb. Like a lot of people in this space trust their AI too much. So it's kind of stupid. And one big thing is to just read the fucking manual. Like, just read the manual. Like, reading the manual is slowly becoming a lost skill. And like, like they like Llama.cpp made a really good inference engine, but they also made documentations for it. So as you can see over here, every single parameter that I talked about is over here, and every single thing has been probably already been done, and like there is just so much useful research, useful information at the manual that you don't really need like to ask an AI. Just go over here. Like there's so much stuff that you can learn about. Now, some more stuff is that I there's just so much things I didn't cover, like higher speculative drafting, like D-Flash, Eagle Tree. These are like more ways to make your AI go faster. There's also like new methods to make it really small, like bonsai. Like I didn't cover multi GPU setups, which is decently common, and RPC mode, which you can use multiple devices to run a bigger model. So you can have like 2 laptops or 2 computers separately. And there's just so much stuff that I didn't cover. Like I probably could write more about this. I sort of just covered the surface of this. I only covered the inference engine. I didn't even like cover like the useful apps, the useful AI programs that you should use alongside this. There, like I said, there's just so much things to cover. I will be honest, I don't usually make tutorials or helpful videos. I like look, if you look at my name, I am trolling. I'm doing a little troll. Have you seen my recent videos? It's a fucking shit post. I want my videos to be a net negative to society usually, other than this video. And I don't know. Tell me what you think of me making helpful stuff, like sharing my expertise without shit posting. And maybe I'll make similar videos like this. But the reason why I made this video, I'll be honest, is that I got rage baited so hard. Because I see people wanting to try local AI out, but they fall into fucking stupid pitfalls. This is the biggest pitfall which I see people fall into using Qwen 3.5, which is a 2-year-old model, and it is just ancient. There's also like quantizing KV cache for some models. Sometimes you shouldn't do it. And people defaulting to finetune because they think it's better. This is like this pisses me off so much, because like people on Twitter and fucking on YouTube who don't know what the fuck they're talking about. They're like, oh fucking Mishosh, Quapush, good, Quishosh, Quable, it's good. No, they just don't know what the fuck they're talking about. And that's why people default to this models. They just use this models because they just don't know better. And yeah, obviously people just giving dog shit opinion. Turbo Quant, I hate Turbo Quant. That's just an opinion. And yeah, using a Llama.cpp fork that's 2 forks deep, because they found it on someone on Twitter says better, so they must be better, right? So there's just a lot of common noob mistakes that people fall into. Now, this entire mind map is gonna be downloadable for free on my Patreon. As well, I will revive it. Last post to February 16, 2025. I swear, I'm gonna revive it. Like, I swear to God. Like, fucking cut off my balls if I don't revive it. So, I'm hoping that this would be a really good resource for people to try local AI out. Because they're generally not bad. Like, they're generally not bad. And it's really interesting on how far local AI has gone. So, I don't know. This is like one thing I'm really passionate about. And hopefully, like, my passion, my knowledge, just it's like fucking. I hope it reaches you. And I don't know. Fuck big corpos. Run AI locally in your computer. It's shit. It's slower, but it's yours. It's your AI. It's not their AI. Thank you and goodbye.